Now let's look at the concept of percent composition. This is the percentage of each element in a compound by mass. And we can determine this percentage two ways, either by looking at the formula of the compound and also from experimental data. Now, the end result from the percentages may not always total to exactly 100%. This bothers some people, but we have to round due to sig figs, and so the percentage total should be close to 100%, but maybe not exactly. Now remember that a percentage is a way of expressing a fraction, and a fraction is some part over the whole. And since our minds easily comprehend values from 0 to 100, when we multiply a fraction by 100%, it allows us to view the fraction in terms that are easy to understand. Now, when we're calculating the mass percentage of some element in a compound, this is how we're going to go about it. We're going to look at typically this is how we're going to go about it. We're going to look at the mass of the element X, whatever that element is, in 1 mole of the compound. And then we're going to divide that by the mass of 1 mole of the compound, otherwise known as the molar mass. So here's our part, the element, and here's our whole, the compound. And then we multiply it by 100. And that's how we get mass percentage, based on the formula. So let's look at this example. Find the mass percentage of chlorine in this compound here. And this compound is a component of Freon. And remember, chlorine is the destructive part of Freon that reacts with the ozone. Okay, so if we remember back to our formula, we need to know the mass of our element in the mass of 1 mole. So let's go ahead and calculate the molar mass of this, and then we'll know what the mass of 1 mole of our compound is. So we're going to break apart our our compound into the elements that make it up. In this compound there are 2 carbons, there are 4 chlorines, and there are 2 fluorines. And then I look at the periodic table to get the masses, and carbon is 12.01 grams, chlorine is 35.45 grams, and then fluorine is 19.00 grams. And these are from the periodic table. Okay, so when we do our math, I end up with a total molar mass of 203.82. And looking at my sig figs, I only have one place after the decimal point in this value, so correct sig figs, my answer is 203.8 grams. So this is the mass of 1 mole. That's my molar mass. And then in this compound, my chlorine made up 141.8 grams. So here's my mass of chlorine in my total molar mass. I'm going to divide this by this and multiply by 100%. So here's our formula. The mass percentage of an element is the mass of the element in 1 mole of the compound divided by the mass of 1 mole of the compound, otherwise known as its molar mass, multiplied by 100%. So here's the mass of chlorine in 1 mole of our compound, and here's the molar mass of our compound. So we're going to divide this first and then multiply by 100. So my calculator tells me 69.5780166%. Let's look at sig figs. 4 sig figs here, 4 sig figs here. Here's my last allowable sig fig since I should have 4. So 69.58% chlorine. And that's a reasonable number, and this looks like it's about 70%. Chlorine is making up a good chunk of the 203 molar mass. So now you practice, see if you can figure out the mass percent composition of the following. And so it's not specifying a given element, so you've got to figure out the mass percentage of both elements in this compound. So pause the slide and work on it, and restart it when you're done. Okay, so the first thing we want to do is calculate the molar mass of this compound. And by the way, should see if you can name it. Calcium chloride. It's an ionic compound, but we don't need a Roman numeral because calcium always has a charge of +2. Okay, so we calculate the molar mass. 1 mole of calcium is 40.08 grams. 2 moles of chlorine is 70.90 grams. And here are my answers expressed in correct sig figs. 4 and 4 mean I should have 4 and 4. Both values have 2 places after the decimal point, so my answer is going to have 2 places after the decimal point. Now let's look at calcium first. To figure out its mass percentage, we take 40.08 grams and divide it by the molar mass. So in this 110.98 grams, 40.08 grams is due to calcium. And when I put this in my calculator, I get, 36.1146%. And let's go ahead and round this to correct sig figs. This has 5 sig figs, this has 4 sig figs. Our answer should have 4. There's my last allowable digit, so 63.11% calcium. Now we could conceivably just subtract this from 100 to get the remaining percentage. That would be totally acceptable in a test. But let's go ahead and do the math and see if our values add up to be 100%. So here is our molar mass of calcium chloride. Here's the mass of due to chlorine. And when I do my math, my calculator tells me 38.8853, etc. I'm just going to stop there. And I should have 4 sig figs because this has 4 and this has 5. So 1, 2, 3, 4. So 63.89. And these two values actually do add up to be 100%, but sometimes when we deal with more than just one or two, when we deal with more than 2 elements, that's when things can get a little dicey. So if you got this right, then you have a great understanding, and if not, just go back and try again, see where you made your mistakes. This, like everything, just takes a little bit of practice.